Good morning, everyone. My name is Egzon BAFTIU. I am the presenter of and the corresponding author of this work. This research was done together with my colleagues from Goethe University in Stip. And today I will present our paper implementation, Internet of Things and cloud-based communication technologies for real-time wind speed and monitoring. In the next 15 minutes, I will show you the problem, our system, our results, and where it can be used. Let's begin. So this is the abstraction, and so I will move it to introduction and objective. Monitoring wind speed is very important in many fields. For example, in renewable energy, in aviation and construction, and for public safety. But today there is a problem. Existing systems and are often expensive and hard to maintain. The data is not always available in real time, and they have limits. The limits. So the objective of our study is simple. We wanted to build a new real-time wind speed monitoring system that uses a modern sensor, Internet of Things and cloud communication. Our goal was to improve accuracy, efficiency, and to make it useful in real situations. Regarding the methodology and system implementation, now we will see how does the system work. The architecture has three main parts. First, anometric sensors collect and the wind data, and second, a secure unit sends this data, and the third, a cloud platform process and shows the data in real time. For the technology, we use high precision digital wind sensors, microcontrollers, and the MQTT protocol over Wi-Fi or LTE. The system also sends alerts for high wind speed, and it is fully scalable. And regarding the hardware components, let's look at the hardware. For the measuring the wind, we use digital anemometers. They are precise and strong in different weather conditions. The brain of the device is a microprocessor based on our Arduino or SCP32. It cleans the data and removes the errors. For communication, we use wireless modules to send the data to the cloud. And after that, we store all the historical data in MySQL database. Regarding the software components, on the software side, the firmware turns the raw sensored signals into the clean digital data. It uses averaging to reduce noises and errors. The data is sent using the MQTT protocol with a secure encryption. Then it goes to the cloud, for example AWS or Google Cloud, for storage and processing. Visualization and system features. For the users, we built a web-based dashboard using HTML, CSS, and JavaScript. It shows the wind speed in real time with a graphs and tables. It also has an alert system. When the wind is too strong, it sends an automatic alarm. The main advantages are real-time monitoring, high accuracy, and remote access from anywhere through the cloud. So we will move forward with a testing, optimization, and system architecture. We tested the system in a real environmental conditions. We compared our results with the standard measurement devices, and we confirmed that the system is accurate and reliable. After testing, we improved the firmware. This made the data transmissions more stable and more efficient. Data processing and cloud. Here you can see the full data flow. First, the raw data from the sensor is cleaned using the Kalman filter. This removes noisy and gives smooth, stable measurements. Then the clean data is sent to the cloud using MQTT. This is the fast, light, and secure. Finally, the data is shown on the web dashboard in real time. So we can see the results of the proposed system. First, we compared our system with professional methodological stations. The maximum differences was only 2%. This shows very higher precisions. Second speed, the average delay from the measuring to the cloud was only 1 to 2 seconds. This is much faster than traditional system, and it allows the decision in near real time. And third, stability. The system worked well even in high winds and extreme temperatures. So discussion and system evaluation. So our system combines three things in one platform: accuracy, speed, and stability. The dashboard is simple and easy to use for users, and both researchers as normal users. In short, the system performs much better than the traditional wind monitoring methods. Uh, this is the table of the parameters: description, result, performance, and deviation. So this table gives a summary of the key parameters. You can see the accuracy of the measurement, the real-time transmission speed, and the ease of use all together in one view. So we can see the histogram and charts. Here are some of our real data charts. The histogram shows how the wind speed values are distributed. Our system can record the changes every 1 second with an accuracy of about half a meter per second. These charts confirm that the Internet of Things and cloud technology give continuous monitoring and immediate access to the data. This is very useful for critical fields like energy or infrastructure safety. So this is the alerts, limitation, and system comparison. The system also sends critical alerts for example, when the wind goes above 10 meters per second, it sends a real-time notification. This allows a faster response. Of course, every system has limitations or depends on the stable internet. The initial cost of the equipment is high and it needs to stable power supply, so we recommend the batteries or solar backup. But compared to all systems which give only periodic data, our system gives continuity real-time monitoring. Wind speed with a moving average and confidence intervals. Why is this important? Wind speed monitoring helps in many sectors. For public safety, it helps prevent the damage from storms and strong winds. For renewable energy, it improves the management of wind turbines. And for research, it gives valuable data to study climate change. So, practical applications and benefits. In aviation, it gives real-time data for safe takeoffs and landing. In agriculture, it helps farmers plan their work. In construction, it protects workers and equipment. In the maritime industry, it improves safety in ports, and in smart cities, it supports energy and environment management. In general, the system increases safety, reduces costs, and support sustainable development. Conclusions. To conclude, in this study, we presented an advanced approach for real-time wind speed monitoring using modern Internet of Things and cloud technologies. By connecting the sensors with a cloud platform, we get efficient data collection, processing, and visualization. Compared to traditional system, our solution is more accurate and more reliable and more user-friendly. Feature and perspectives and impact. For the future, the system can help in wind energy management, in weather forecasting, and in infrastructure safety. Our next step is add artificial intelligence and machine learning. This will help to better analyze wind patterns and to improve our prediction. In the future, this can lead to fully uh, autonomous systems and renewable energy. So, thank you. So, to summarize, our Internet of Things and cloud based system improves accuracy and reliability and the response time compared to traditional methods, and it supports many important sectors from energy to agriculture and aviation. Thank you very much for your attention. I am happy to answer. If you have any questions, please let me know. Thank you so much.